Dear 8th standard students, in the last video we have discussed combination reaction, and now we'll discuss decomposition reaction. Right? In a decomposition reaction, one substance break down into two or more simpler substances. One substance break down like AB. Okay, one reactant, it break on supply of energy, heat energy, light energy, any electricity, any other kind of energy, and break to form two or sometimes even more products. Minimum two or more than two products are formed. So in a decomposition reaction, there is one reactant, two or more products are there. Right? So we'll discuss this decomposition reaction now. And decomposition, one example of decomposition reaction is decomposition of water on electrolysis. What is electrolysis? Electrolysis is a process in which substance is decomposed, broken down into simpler substances. Okay, how? By passing of electric current through it. And the best, easiest example for you is decomposition of water on passage of electricity. So electrolysis of water is an example for you. And what is there in this? We take water and we add a few drops of acid in it. Right? After adding acid in water, we call this water having acid in it as acidulated water or acidified water. And when we pass electricity through this water, it breaks down to form hydrogen gas and oxygen gas according to this equation. Here you put two water on passage of electricity form hydrogen and oxygen gas. Hydrogen gas and oxygen gas is formed. So what is done in this experiment? We take water, we add few drops of sulfuric acid in it, and we take two test tube filled with water. This acidulated water, we fill it in two test tube completely, fully. Then on the mouth of the test tube, we put our thumb and then we invert it. Okay, ulta kar de, invert it into this beaker in which already acidulated water is there. We inverted inside. Same way the second one also is inverted here. So in the beginning, these two test tubes are fully filled with water, not up to here or here, fully filled with water in the beginning. Right? And then we take two pieces of wire, two separate pieces. One end of the wire, from the one end of wire, insulation is removed. You know, on the wire insulation is there, rubber insulation is there. That insulation is removed from two ends of the wire, separate wires, and one end of the wire is placed here inside right hand side test tube, and other end is of second wire is placed from which insulation is removed inside this second test tube on the left side. And this wire, right side test tube in which wire is put here, this wire is connected with positive terminal of the battery. So this wire will behave like positive terminal and we call it anode. Positive terminal is anode, and negative terminal of the wire, this wire is connected with negative terminal of the wire. You know, cell have two terminal, positive, negative. So one is connected with positive terminal anode, one is connected with negative terminal, that is called cathode. And then circuit is put on, electricity passes, and what we see, bubbles of the gases are seen in the two test tube. But we don't know which gas is this there because both are colorless. Right? Then after some time, when these test tubes are fully filled with the gases, then we stop the supply of current, and inside in the mouth we put a cork, and then we take it out. Right? And with these gases, two gases are there. Now we carry out certain tests which are shown here. The gas collected at the negative terminal, negative one, this one, okay, negative terminal, cathode. This gas near to the mouth of this test tube containing that gas formed at negative terminal, we bring one lighted matchstick. Okay, lighted matchstick, tili, jaldi hui tili. We bring it near to the mouth and you open the cork mouth. Okay, or open the mouth of the test tube. Then what we find, the gas burn and burn with a pop sound like that, right? Like this it will burn, and that gas which burn with a pop sound is hydrogen gas. So this is a test for hydrogen. And then we bring another test tube which is connected with positive terminal, this second one, positive terminal. And we bring a glowing matchstick. See, if you burn a piece of wood and completely, so that it burns a little bit, this much is burnt already, then you put off the flame by blowing air. Okay, then that part of the stick is still glowing red, right? ਜਲਦੀ ਹੁੰਦੀ ਹੈ, ਪੰਜਾਬੀ ਚ ਕਹਿੰਦੇ ਧੁੱਖ ਦੀ ਲੱਕੜੀ, and in English we call it glowing matchstick. When that matchstick is brought inside the second test tube, then it is relighted, gets lighted. Lighted means flame of the stick, glowing stick comes back. That means the gas is a supporter of combustion. And what is that gas? This gas is oxygen gas, right? And one more thing, if you see carefully here, in case of left hand side test tube which is connected with negative terminal, cathode we call it, empty space above water level is double than that of second test tube. It means volume of hydrogen is 2 times of oxygen, right? So 2 volume, if 2 liter of hydrogen is formed, then how much oxygen is formed? Just 1 liter. So this is the electrolysis of water. Now come to decomposition of potassium chlorate, sodium bicarbonate, that is baking soda, mitha soda we call it. This is sodium bicarbonate, mitha soda. What is it? Mitha soda, sodium bicarbonate, right? When you heat it, it break to form sodium carbonate. This sodium carbonate is also called washing soda, right? Washing soda. Earlier it was used for washing purposes, or we call it soda ash also sometimes. And water is formed and carbon dioxide is formed. See, one reactant, 1, 2, 3 products are formed. So this is a decomposition reaction. On heating, this reaction is brought about. Second is potassium chlorate, decomposition of potassium chlorate. When strongly heated, potassium chlorate KClO3 break down to form 2 products, potassium chloride and oxygen. Clear? So therefore this is also decomposition reaction, right? Dear student, next topic is displacement reaction. What is it? Displacement reaction. See, in a displacement reaction, one element displaces another from its compound. One element, they have simply one element, but you should write one more active element. More active element displaces another element, less active element, right? So more active element displaces less active element. And how you come to know which element is more active and which is less active? That will come to know from activity series, right? In this activity series you have to learn the element which is higher is more active and the one which is lower is less reactive. So the element which is higher will displace the element which is lower in the activity series. So displacement reaction are studied using activity series. In the activity series, metal along with hydrogen are arranged in order of activity. Higher an element is placed in the series, more activities, means that element which is higher is more active, the element which is lower in the activity series is less active. So potassium is most reactive and gold at the end is the least reactive. Or you can say potassium and magnesium, if I compare, potassium is more active, magnesium is less active. If I compare aluminium and zinc, aluminium is more active, zinc is less active. If I compare magnesium with copper, magnesium is more active, copper is less active. If I compare hydrogen and copper, hydrogen is more active, copper is less active. Do you understand? This is what is explained in this paragraph. They have taken few examples, I have taken so many. Now come to the next side. What is here, beta? See it carefully. Here could you say in what order will the activity of copper, silver, magnesium, iron, aluminium decrease? So among these 5 metals, which is most active, beta? Magnesium. If you just check the activity series, magnesium is above aluminium, second is aluminium, third is iron, then comes the turn of copper, then last one is silver. If you check the series, accordingly you can arrange. It has been observed that more active metal displaces less active metal. This is very important. These are very important lines. This should be there in the definition also. Now displacement of hydrogen from water by a metal. See, when you put a potassium, sodium or calcium metal in water, and water should be cold. Even if water is cold, then also reaction takes place. Potassium displaces hydrogen to form potassium hydroxide and hydrogen gas. See why potassium displaces hydrogen. Look here, potassium is more active, here you see, and hydrogen is less active. So more active element displaces less active element. And maybe you don't understand how, sir, how it displaces, we can't understand this and that. I'll show you. See, this is potassium, and overall what is the reaction? What is the reaction? I'll show the reaction first of all. This is the reaction which is there in the book, right? Potassium plus hydrogen, water react to form potassium hydroxide and hydrogen. Now how actually it react? Potassium, 2 potassium atoms are there. Water, I am writing water as HOH. What is water? Formula water, HOH only. This potassium displaces 1H. Out of 2H, 1H is replaced. So potassium displaces this H. In place of H now I can write K. So OH as it is, KOH. Same way second potassium displaces second H and another KOH is formed. And this hydrogen is also displaced, this hydrogen. 2 hydrogen are displaced and 2 together form hydrogen gas. So see, potassium displaces hydrogen in this reaction, right? Now same way sodium. Sodium also displaces hydrogen and sodium hydroxide in water to form sodium hydroxide and hydrogen. Calcium also displaces hydrogen to form calcium hydroxide and hydrogen in cold condition. Magnesium, next metal after calcium is magnesium. Magnesium is less reactive than these 3, right? So therefore magnesium do not react with cold water, but magnesium react with water on boiling, but reaction is slow. But same magnesium, when it is introduced in steam, then magnesium displaces hydrogen. But when water is hot or water is in the form of steam, then one product is hydrogen. Here also in case of cold water also hydrogen. But the second product, when the water is hot or steam in the form of steam, the second product is oxide of the metal. Magnesium oxide is formed here, right? So this difference is there in comparison to cold water. Steam will have slightly different product. Magnesium oxide is formed. In this reaction, magnesium atom displaces 2 hydrogen atoms to form magnesium oxide and hydrogen gas. And here magnesium burning is there. It is introduced in steam. Steam is formed here in this setup. Steam is coming out, and burning magnesium, we have to burn magnesium outside, then introduce it. That magnesium continuously burn. That means magnesium is reacting with steam. A less active metal like magnesium, zinc, iron easily displace hydrogen from dilute acids. HCl, dilute hydrochloric acid or dilute sulfuric acid. See, zinc react with HCl, zinc displaces 2H to form zinc chloride and hydrogen gas. So again more active zinc, you can see the activity series, zinc is above hydrogen. So zinc is more active, displaces hydrogen to form zinc chloride and hydrogen. So this is also displacement reaction. Iron and sulfuric acid. Iron displaces 2H to form iron sulfate and hydrogen. So this is also displacement reaction, right? Displacement of copper from copper sulfate by iron or zinc. See, test tube I'll show you afterwards. Here you see, first of all, if you take in a test tube copper sulfate solution, which is blue in color, here blue solution, copper sulfate solution is blue. Add iron, here they have shown iron nail is put inside, right? Iron is more active, you can see here, iron is here and copper is here. So which is more active? Iron is more active. So iron kick out copper, this copper is displaced by iron. So in place of copper, iron is there now, ferrous sulfate is formed, and copper is just kicked out away from the solution. So this is also displacement, and iron is more active than copper, therefore iron displaces copper in copper sulfate solution, right? And you see here, blue solution of copper sulfate, iron is put in, reaction takes place, and after some time solution turns light green. Why light green? Because ferrous sulfate form, FeSO form, is FeSO4 is light green solution. And on the nail you see reddish brown material is sticking to it. What is that reddish brown material? Copper metal form. This copper metal form, okay, is sticking to the nail. So this also is a displacement reaction. And here also you check, zinc is also more active than copper, so zinc displaces copper to form zinc sulfate and copper metal. So these are displacement reactions, right? Now come to double displacement reaction. What is that? Double displacement reaction. In a double displacement reaction, positive and negative radicals of two reactants are exchanged, leading to the precipitation. Precipitation means solid is formed. When two clear solutions are mixed, solid is formed. That is double decomposition. Double decomposition or displacement reaction, double decomposition also we can call it, double displacement also we can call it. Two names are there. Double displacement reaction are very fast and the precipitate is formed as soon as the reactants come in contact. These are fast reactions. Quite often the color of the precipitate is different from that of reactant. Okay, color of precipitate formed, solid formed is having different color. The following are the common example. See, silver nitrate is a clear solution like water, clear solution, colorless solution. Sodium chloride solution, you already know, if you add sodium chloride, common salt to water, what kind of solution is this? Colorless only. So both colorless solutions are mixed, you mix and immediately white solid is formed, silver chloride is formed. And another product, sodium nitrate, is formed, which is colorless, which we can't see. That is there in the solution only. Now what happens here? This silver is a positive ion, okay, and nitrate is a negative ion. Here sodium is positive ion, chloride is negative ion. So what happens? Positive ion of one reactant combined with negative of the second, silver with chloride, and positive of the second combined with negative of the first. So positive and negative radicals are exchanged, interchanged in the two compounds, and here they are showing by this method. Silver nitrate have silver positive ion, nitrate negative ion. Sodium chloride have silver positive ion, chloride negative ion. So positive ion of silver chloride, silver nitrate combined with chloride of sodium chloride, silver chloride is formed, and positive of sodium nitrate, sodium ion combined with negative ion of silver nitrate, that is nitrate ion, to form sodium nitrate. So these kind of reactions are called double displacement reaction or double decomposition reaction. Another example of this kind is given here. Reaction between barium chloride and sodium sulfate. This is barium chloride, this clear solution. This is sodium sulfate, again this is clear solution. When these two solutions are mixed together, immediately double decomposition takes place. Positive ion of barium chloride, that is barium, combined with negative ion of sodium sulfate, that is sulfate. Barium sulfate is formed, and positive ion of sodium sulfate, sodium, combined with negative ion of barium chloride, that is chloride, sodium chloride is formed. So two compounds are formed, out of which one is solid, that is barium sulfate. So white precipitates are formed immediately. Immediately white precipitates are formed. So this is double decomposition reaction, or sometimes we call it precipitation reaction also, if one of the product formed is solid. Right. Now next topic is neutralization reaction. In a neutralization reaction, an acid react with base forming salt and water. One acid, one reactant is acid, other reactant is base, and they react to form two products only, salt and water only. So that is neutralization reaction. Acid as well as base lose their properties. When acid and base react, they lose their property. You know, in a chemical reaction, new substances are formed, means old one lose their properties, right, and form salt and water only, right. And salt and water, they are not acidic nor basic, right, they are neutral. This is called neutralization reaction. And example, you see, HCl is acid, hydrochloric acid in the solution form. NaOH is also base, it is in solution form. And here also neutralization takes place, salt is formed. How you find the formula of salt? See, from the base take the positive ions, metal ion normally, sodium, and from the acid take the negative ion, H is positive, chloride is negative, and Na and Cl, they will combine to form sodium chloride. Salt and water is always formed, sodium chloride and water. Here if you check sulfuric acid and KOH, potassium is negative ion, and what is the positive ion, sorry, potassium is positive ion, and what is negative ion of sulfuric acid? Sulfate. So which salt will be formed? Potassium sulfate, K2SO4, plus water always there. Now come to sulfuric acid and NaOH. In base, Na is positive ion, in acid sulfate is negative ion. So sodium sulfate is formed and water is formed. This is also neutral, salt and water. This is also salt and water. This is another salt and water. This is not salt, doesn't mean common salt always. There are different kind of salts, many kind of salts are there. Although what the salt which we use to make our recipes or food, that is sodium chloride. That is common salt, we call it. These are also salt, but we cannot use it for cooking. HCl and calcium hydroxide. Calcium metal, chloride, negative part of acid. So which salt is formed? Calcium chloride and water. HCl and aluminium hydroxide. Aluminium is metal and Cl is chloride ion. So which salt will be formed? Aluminium chloride, AlCl3, plus water is formed, right. So this is neutralization reaction. And here one activity is given now. Take about 5 ml of sodium hydroxide in a conical flask you take, vessel, and dilute it with the test tube water and some water also in it. Swirl the flask, ensure thorough mixing, means mix it thoroughly, and add a drop of phenolphthalein solution. Phenolphthalein solution, it is an indicator, right. Then what happens, you know, this is base, and when you add some phenolphthalein in it, it turns pink. Phenolphthalein gives pink color to the base, so it turns pink. Right, the phenolphthalein is indicator, which is a pink, red or pink in basic solution and colorless in neutral solution and acidic solutions, right. Now add hydrochloric acid drop wise to it, slowly, drop hydrochloric acid, HCl, you can add, and keep on stirring it. Swirl means keep on stirring it, right. Add the acid till the pink color just vanishes. If you keep on adding drop of acid and keep on mixing, then a stage will come with one drop, the pink color of the solution disappear, it becomes colorless, right. That means neutralization of base, which we added in earlier, NaOH is added earlier, that neutralization of base is complete, right. Now what is formed there? Salt and water, right. Salt and water is there, and the solution becomes neutral, and this process is called neutralization, right. Okay beta, so in the next video I will discuss oxides and their nature, and then we will be able to finish the chapter. Thank you.